My name is Sivji. You can find me on Twitter at Sivjus. I'm one of the organizers of the Chicago Python users group. We call ourselves Chippy. There's a lot of material to cover, so let's just get started. A point about notation, you're going to hear me say dunder quite a bit in this talk. This means double underscore. For example, when we have double underscore init double underscore, we can shorten that down to dunder init. In Python, everything is an object. But what does this really mean? An object is an entity that has data and that has behavior. We can create objects from classes, and each object instance has values associated with it. Going up a level, when we take a look at the type of object that we created, we can see that it's the class that it's derived from. And this is true across the board. Strings are str objects, integers are int objects, lists are lists, and so on and so forth. In Python, everything is an object. So this is great and all, but what's my point? Guido van Rossum, the creator of Python, wrote, "I want all objects that could be named to have equal status. These objects can be assigned to variables, placed in lists, stored in dictionaries, passed as arguments, and so on and so forth." Another way to say this is that objects are first-class citizens in the Python programming language. It shouldn't be a huge surprise that functions are also objects. Specifically, they are objects of the type function. And since this is an object, we can pass them into other functions. So is this useful? Turns out it is. Say we have a list of movies we want to binge. We can use the built-in sorted function to get these movies in alphabetical order. But if we want to binge the greatest movie series of all time in the order it was released, we're going to have to sort them in a different way. So we can do this by passing in a function specifying how we want to sort our list. Here we're going to specify that we want to sort by the release year attribute inside of that named tuple. All of this, it got me thinking. If objects are created from classes, but everything is already an object, what do we really need classes for anyways? In this talk, we're going to conduct a thought experiment. We're going to write some object-oriented code without any classes. So let's start with a quick review of object-oriented programming. Classes are templates that allow us to create objects, and we can access an object's attributes, that is, its behavior and its data, using dot notation. Objects have data, and these are values that are stored inside of the instance dictionary, and we can retrieve this dictionary using the instance dunder dict. Objects also have behavior, and we can find this information in the class dictionary. This dictionary contains built-in methods and custom methods that we just created. Our example throughout this talk is going to be building a chess engine. Chess is a game that has 2 players, an 8x8 board, with ranks or rows numbered 1 to 8, and then we also have files or columns labeled A to H, and we have a bunch of pieces. And there's a bunch of different pieces, they move a bunch of different ways. For our purposes, the game is over when the king is being attacked and has no place to go. So let's just write some code. We're going to start off by creating a class for our piece. No, wait, scratch that, we're not using classes. Sorry, it's just a bit of force of habit. We're going to start off by creating a function called piece that takes in a color. And just like what an object does behind the scenes, we're going to store this information inside of a dictionary. And then we're going to close this function by returning that dictionary. If I was designing an object-oriented solution, piece would be my base class, and then I would create all of my other piece types using that base class. But how can we replicate inheritance hierarchy with just functions? We can use functools.partial. So functools.partial, it's going to take in a function and some arguments. This could be positional or keyword arguments. And it's going to return a partial function. And this partial function freezes that function we pass in with those function arguments or those function keywords. And then we're going to reduce our function's signature. It's just going to simplify it. So how does this help us? Going back to that example, we can update our function to accept a type argument, and then we can add that argument to our internal dictionary. And just like before, we're going to return that dictionary. And now we'll use functools.partial to initialize our piece with the type equals queen. And the resulting partial object, that's going to be saved in our queen variable. Now we can create a queen piece and access its attributes using the dictionary notation. We just implemented inheritance with functions. This is great, but dictionary style access, it feels a little bit weird. It makes sense since our underlying object is a dictionary, but is there any way we can hack together attribute access? Enter types.simple namespace. This is an object that provides attribute access to a namespace. If we initialize simple namespace with keyword arguments, those are going to be directly added to our underlying namespace. For example, if we have a dictionary called data, we're going to import simple namespace, slap that dictionary into that constructor, and now we can actually go out and use dot notation to access those attribute values. Jumping back into the code for a piece function, we'll wrap our dictionary inside of a namespace, and then we're going to return that back to the caller. Now that we have that piece function that behaves like an object, we can create all the piece to objects that we need to initialize our game. So the next step is to set up our game board to initial state. In chess, this looks as follows. So we're going to start off by creating an empty dictionary. We're going to cycle through each of the squares on our board, set their values to none. Then we're going to just put all the pieces where they belong. So here we're just going to initialize all of our white pieces. Next, we're going to initialize all of our black pieces. Finally, we're going to return our dictionary that we just created. Now we can start our game. The object that we got back, it looks like this. It doesn't really do us any good. Our users are probably going to want to see some sort of graphic representation. So let's take a look at that. Fortunately, characters for our the chess pieces, they're available as emojis. So we can just create a simple mapping table. And now our drawBoard function, it's going to take in a board. We're going to cycle through all those squares inside of our board. And then for each character, we're going to add it to our string. And then finally, we're going to just print the string we just created. If we run our code, it looks like this. It's not as nice as the example from earlier, but it's pretty good with just a few lines of code. Taking a step back, let's take a look at that drawBoard function. If we look at that function, it's pretty indistinguishable from object-oriented code. The only way we know that this code doesn't use any classes is by going into the implementation. We still haven't implemented piece movement, but we're running out of time. I won't be able to talk about things like inner functions or closures, but I did include links later on that you can use to check out at your leisure. What can I say? Estimating things, it's a little bit hard. I hope to write up a blog post or maybe a lightning talk at NextPy Ohio. So let's recap. Using built-in data structures and the standard library, we can write functions that mimic the behavior of classes. This is great, but our code, it's a little bit of a mess. You never really want to do something like this in production. Recall from the Zen of Python that simple is better than complex. If we're doing all this work just to replicate the functionality of a class, why don't we just use classes to begin with? I also want to note that we don't have to dig into C Python source code to understand the internals of Python. If we just introspect our objects, we'll get a lot of insights into how Python functions underneath the scenes. One of the things I learned was that objects, they're just nice wrappers around dictionaries. And the more you dig into Python, the more you see that dictionaries, they're one of the primary data structures inside the programming language. Here are links to some additional resources. So thanks everybody for your time. I do want to give a shout out to Chicago Python. I would not be where I am without that fantastic organization. So thanks again. My name is Ali Sivji. I'll see y'all in Columbus for Pi Ohio 2021.